We are going to take a brief look at problem 21 from chapter 15. There's a picture for problem 21 here. If it takes 35 seconds for the 50 megagram tugboat to increase its speed uniformly to 25 kilometers per hour starting from rest, determine the force of the rope on the tugboat. The propeller provides the propulsion force, which gives the tugboat forward motion, whereas the barge moves freely. Also determine F acting on the tugboat. The barge has a mass of 75 megagrams. So, in this problem, this is 21, we have delta T is 35, we have the mass of the tugboat, we have the mass of the barge, we have the change in velocity given to us. The change in velocity is 25 kilometers per hour. We can convert that to meters per second. We want to find the force F and also the tension in the rope, which I'm calling T. We want two forces here. In order to do this, we're going to have to look at two different systems using our impulse-momentum relationship here. Since these forces are constant in time, we can pull that net force that we have here outside the integral. That gives us F net times delta T. We can bring that mv1 over to the other side, and that gives us the mass times the change in velocity. So this is our impulse-momentum relationship here. If I look just at the barge, which has a 75,000 kilogram mass, there's only one force acting on that in the horizontal direction, and that is the tension in the rope. I know, so I can use the impulse-momentum relationship for the system of just the barge. The mass times the change in velocity is equal to the net force, which is just T, times the 35 seconds that I have here. So I can do that, solve for the tension in the rope, and that's what we have here. Now I can do the impulse-momentum relationship again for the system of both the barge and the tugboat. If I do that by Newton's third law, the tension that I have acting on the barge is equal and opposite to the tension that I have acting on the tugboat, so those forces cancel out, and I just have the force F acting in the horizontal direction. This mass is the total mass of the system times delta V is equal to the net force times delta T, and we can solve that for the net force. And that is a brief look at problem 21.